Okay, welcome. We'll get started. So how many people were over and used Trig? I felt I got kind of ambushed over there. I saw a lot of you over at the interview sessions, which was good. I was thinking coming over here, it would have been easier if we just did one big mass recruiting session in here. But no, it was good to see everybody over there. Recruiting season is in high gear. Freescale is targeted. SMU is one of our top schools to recruit at, so that's good. It says something positive about the engineering department. Also, our CEO of the company, his son is in the engineering program, so that may have been one reason why he chose SMU to be on the select list. So, but no, it was good to see everybody over there. For those that did, so basically what happens is we're going to take all the resumes back. We're going to different people are going to look at them, and there'll be some follow-up calls, and some of you will get emails, phone calls asking for more information, or just have another conversation. So, so hopefully that'll go over well. If you have any questions, let me know. A lot of this, again, will be handled by different business groups, not all by me. So the odds of me contacting you, we'll see. I think I've got some openings with some of my managers in Austin, but I'm not sure. So we'll see how that goes. But thanks for coming by. It was good to see everybody. A couple questions about the homework. I think I got caught up with most of the homework, 1 and 2 anyway. And I think for those that, if you got most of the points or all the points, I didn't post a example solution. For the others, I tried to post a sample solution. If you didn't get one, let me know. I think I did miss out on a couple postings of the sample solution. So if you didn't get one, just send me an email. Overall, they were pretty good. The one thing that was, I think a lot of people missed was in the part on asking you to for non-functional requirements. There were I still got a lot of them that were written in kind of a vague way. You know, like I was still seeing some that said, you know, the system has to be easy to use. Remember we talked about all these things have to have some kind of quantitative value, something. And the way I judge it is when I read the requirements that you've written, if I can easily figure out how I can test it and know whether that test passed, to me that's a well-formed requirement. If it was vague, like easy to use, how do you test that? Or it has to be fast. I'm just making up a couple of examples. So go back and look at that. There were some that did it well. You know, every one I read, there was a kind of a quantitative value in there, so I can read it and tell whether I can test it and actually meet a criteria for passing. And so again, there was no low marks on the homework at all. Everyone did pretty well. But if you're wondering why, before you drop me an email, go look at that first, because a lot of people kind of missed that part. Maybe I didn't state it properly. I don't know. But that's what I was looking for, is a well-formed, testable, quantitative requirement for the non-functional class, or the quality requirements, however you want to refer to it. That's the only thing I really noticed. If there's any other questions, drop me a note. Admittedly, one thing I'm bad at, and I'll try to get better through the semester, is if I post the sample solution and I post your mark, sometimes I don't write a lot of comments like where you lost points. I'm trying to get some new technology that'll allow me to make that easier. But I'll certainly answer any questions if you can't figure it out. But first look at the sample solution. I call it a sample solution because many of these have many different possible solutions. Look at that. If you still have questions, drop me an email, and I'll get back to you and give you more specifics. Okay, does that make sense? Okay. Okay. Next administrative point. Next week I will not be here. I have to be in Europe all week long. So what I'm going to do for class next week is I'm going to give you a link to a lecture that I did in a previous semester. I'm going to try to align it the best I can to where we are in the course. It may not line up exactly right, but it'll be relevant. And so you'll see that information go out here shortly. So you don't have to come to class. I'll just send you the link, and you'll still get the lecture hours. Okay. I posted homeworks 4 and 5 online, some of which we'll talk about tonight. We're going to get into some topics like use cases, and even though I think some of you might be familiar with this, we're still going to have a discussion on that tonight, and a few other different brainstorming techniques for eliciting requirements. Those are some of the topics for tonight. But the homeworks are out there. You'll see them. That'll take you through the next few weeks. I think all the due dates are on there. And then finally, it'll just as a heads up, let me just pull this up here. I'm targeting October 21st as the midterm. if you have a problem with that, let me know. The reason I'm targeting that is number one, I normally have those proctored. You'll have all class to do the midterm. So just show up, you'll have all class. It's closed book, closed note. I'll say more about that when we get closer. But the other reason I wanted to line it on that week is that's the other week I have to go back to Europe. And I'd rather not have to miss another class. So if I put the midterm, which is usually it's going to be either that week or the week before. So if it's that week, we don't lose any additional class hours. So that's why I'm choosing October 21st. So let's put that on the books for now. If you, as with all these these dates, if you have a specific conflict, if some of you are traveling, we've got about 40 people in the class total, and some people are working. If you're traveling, let me know. We can work out something with Deborah to proctor you in another time. But just let me know if you have a conflict. I can't take conflict excuses like I'm really busy, but I can take one if you like really have something going on and you can't make it. But drop me a note if you're going to have a problem with that. Okay. A couple more interviewees coming into the class. Okay. Any questions on any of those announcements? Any other questions on anything else? No? So again, I've gotten some more emails on project selections. That's good. A lot of the material we're talking about, again, some of that is applicable. The frame diagram, that's applicable to the project. You'll see that in there, et cetera. So you can start going on the project as soon as you form your teams. So if you haven't done so, try to get on that as well. Okay, let me plug in. We're going to pick up right from where we left off last time. We were just starting to talk about some elicitation techniques, and some of this, we'll go through it pretty quick because there's not a lot of technical content here, but it's important if you're going to be a requirements engineer to kind of know about some of the basics, okay? I've been on my feet for 2.5 hours at that interview session talking, so if I start to lose my voice, bear with me. I'm also tired, so if I fall asleep, just throw something at me. Okay, so remember this picture? The key concept here was, as we start the process of the journey of developing a requirement specification, early on, we're actually not doing much writing. We're doing a lot of talking. We're doing a lot of researching, interviewing. We're going to talk about some of these techniques to try to gain an understanding of just what it is we're trying to, we're actually trying to build. Once we start getting some well-formed ideas, we'll start writing this down. And so you see the gray area, that starts after we do a little bit of research, and after and then eventually, early on, it's a lot of elicitation, talking to people, trying to find different sources of requirements, a lot of things we've been talking about, and then we'll start writing it down. And then also validation. We have to make sure that what we actually think we heard and what we think we're supposed to do, we actually have to go through a process of actually kind of validating that. And I'll talk about, there's a whole section on how we do that as well. Okay, so let's kind of dive into a few of these areas over here, these elicitation techniques. Again, there's a whole bunch of them. I'll talk about a few that are important. I tried to pick the ones that I do the most in my job, and I'll try to give you some examples and case studies about how these things actually work. So like this first one, and it seems pretty, speaking of interviewing, I was just interviewing a whole bunch of people. But this is actually, it sounds simple, but it's actually pretty difficult to do. And I'll explain why by giving you some actual things that happened to me in industry that made me, made me shiver because of the way it was done. It's kind of scared me. I'll talk about it. Now, what is the idea behind interviewing? Well, hopefully you're trying to interview your customer or someone that's going to use your product, some stakeholder. And, but it's not just, you can't just go up and start talking to a person. You'll never get what you need to know. And I'll give you an example of why this is not always easy. So I was a project manager for a company, and we had to do some work with the New York Stock Exchange. You've heard this place, right? And the way the New York Stock Exchange does trades these days, it's not like what you see on the movies where you have a whole bunch of people with these pieces of paper and they're yelling and screaming. And you ever see that in the movies, right? Well, it's actually not done that way a lot. It's done that way in some mercantile exchanges, but in the New York Stock Exchange, really the way a lot of the traders perform trades is they have these handheld devices, kind of look like phones, like a smartphone, and they actually take trades on these handheld wireless devices, and they connect to these locations within the trading floor, and a lot of the trades are done that way. And so what we were doing is we were building, or the company I was consulting with, they were building the user interface for this wireless device to allow the traders to make trades more efficiently and keep track of what they've done and all the other cool things that come with automation, okay? So we wanted to interview one of the users, which is an on-the-floor trading specialist, right? So these are the guys that are on the floor. And so problem number one, we can't get on the floor. You can't get on the New York Stock Exchange. You have to have a certain pass. Just to get a quote-unquote seat on the New York Stock Exchange, you have to pay like $150,000, $200,000. These are not, you don't just walk in, right? So we couldn't get on the floor. And the guy we're trying to talk to wasn't motivated to leave the floor to talk to us because when he's on the trading floor, he's making a lot of money, right? Making all these trades. He doesn't want to take time out of his busy day to talk to us. So after a lot of back and forth emailing and at nights and stuff, he finally agreed to meet us at 4 o'clock, right when the exchange closed, and to give us 1 hour of his time. That's all he had. Remember, these guys are busy. They make a lot of money. There's a lot of stuff going on. So he finally was able to carve out 1 hour of his time to talk to us about the new requirements for this handheld wireless trading device, okay? So we have 1 hour. So now, there's some constraints. 1 hour, maybe once a year we get to do this, right? So 1 hour and that's it. The product's out by the time we talk to this guy again. So now, would you think differently about how you're going to interview this guy? First of all, are you going to prepare a little, would you prepare a little bit better knowing that all you have is an hour? And other things I'm going to talk about now. But that's just, to set the stage, I'm just giving you a little bit of an example of sometimes why it's so difficult just to have a basic interview with the right person. If you interview the wrong person, you're not going to get the right information. So you want to interview the person that's actually going to use your product. Okay, so I listed a few things here that that are kind of rules to follow. I'll go through them quickly. Like, for example, you think, well, just ask permission to take notes. Well, you kind of have to ask permission to take notes. Some people, just like any other reporting you see on TV, some people don't like to divulge certain information to you, and so you have to actually ask permission to take notes or to record them. You don't want to turn on your recorder without telling them. Very bad idea. Now, in some companies that I've also talked to in Asia, like Huawei, ZTE, these are big telecommunications companies in China that I've had similar experiences with. You can't even take your computer or phone into the building. You have to check it outside. They don't want anything in. If you want to upload a presentation, you have to load it on an external server out in the lobby and then let them get access to it. You can't bring anything into the building for competitive reasons. They don't want anybody taking pictures, recording, anything. You can take notes. So it's not always easy. That's the point I'm trying to make, just to get a basic, simple interview in the real world. And so you have to prepare accordingly. So ask permission if you're going to record them or take notes. You need to express interest in what they're doing. If the person you are talking to, which is, again, hopefully is probably one of your customers, if they sense that you don't want to be there, you're not interested, or you haven't prepared adequately, they're going to very quickly feel like they're wasting their time. Okay? So show some interest, do some research. You want to listen. That's why we're given 2 ears and 1 mouth. You want to listen more than you talk. And this is something also that is very easy to get into a discussion. And believe me, I've done this. engineers like to talk. We love to talk about the things that we do. And I found myself, even after many years of doing this, spending more time talking to them about the cool stuff we're doing as opposed to listening to what they need. Okay, and this is human nature to try to, especially engineers, we love to talk about what we do, but when you're trying to gather information, you have to listen to what they want, not try to sell them on what you're doing. You see the difference? Start small is okay. You don't want to dive into the details, so I always begin with at least 5 minutes of various topics. If I know the person well, I'll ask about his family. If I don't know them at all, I'll talk about something of interest, the soccer game, where I went to the Great Wall on the weekend. It was I'll talk about something, and start small, but then get into the subject. Again, you've got an hour, let's say, and the clock's ticking. A lot of people that you interview are going to be, they're going to take time out of their current workday to talk to you, and so you don't want to feel like you don't want them to feel like you're wasting their time, or you haven't prepared, because they're going to get back to the next meeting. They have to go write some code, and they're giving you some of their time. You want to respect their time. So that's why you want to keep to the subject. It's always good to see the working environment. I always, for those who had my user interface class, you've heard me say this before, but there's really 3 types of analysis that you want to do when you're in one of these sessions. One is what's called user analysis. You want to understand the types of users that you're building your product for. What kind of experience do they have? What kind of training do they have? So user analysis, you want to do task analysis. What are they actually trying to get done? And then the third one is workflow analysis. You want to understand how do they operate with your product within the broader workflow. So with my, the last time I did this, we were selling them some development tools that they used within their networking lab. And so I asked to see the lab. Can we just kind of look in the lab? This is important because you get a chance to see, okay, what is it like from a lighting perspective? Just the lighting can have an impact on the type of user interface you develop. What kind of noise? How crowded is it? Things like this. You get an assessment of the product within their working environment. You want to describe the exchange of information. In some cases, the interview cannot be done unless you have a non-disclosure agreement, an NDA in place. So sometimes this is a deal breaker, like you can't even start a discussion unless there's an NDA. So you always want to check these little things to make sure that these things are in place before you start exchanging information. Because more than likely they'll tell you some things that are company sensitive, or you'll need to get information that's company sensitive in order to get the right form of requirements. So you have to make sure you have these things in place. You don't want to interview, for example, a manager if the product is intended for their developers. A manager is going to give you very kind of watered down information, not really know what the real challenges are. You always want to go to the real user. So choose the right people. Sometimes this is hard to do. When I did some sessions when we were interviewing people that would use a website, for example, sometimes it's hard to get all the right people. You can do this with some pre-interview questions and things like this, but you want to try to get, otherwise, again, you're not going to get the right information. And then this one here, context-free questions. You don't want to ask yes/no questions. My teenager is brilliant at this. It seems like everything I ask him is either yes, no, or nothing is the response. And so you want to get more information than yes and no's. So context-free questions, like the ones I have down here, are open-ended questions are the ones you want to ask. These are the ones that will give you the most information. There are some interesting yes/no questions that would make sense, but you want to focus on getting as much information in the time you have. So context-free questions is really what you want to try to do here. You don't want to lead them down a path. One of my stories, I took a young engineer. He was a product manager. Now, a product manager in the company I was at is essentially the equivalent of a requirements engineer in many cases. So he wanted me to come with him to interview customers. We were in Israel, talking to a customer that was a very experienced customer. They were very hardcore developers, and he was the guy I was with we had a new product, and he was really excited about this new product. So he went into to this group of very senior developers, and he said, so do you guys test your software? That was his opening question. Do you guys test your software? It's almost an insulting question to ask to senior guys. Do you test your software? What do you think they're going to say, right? They're gonna, so the response was exactly what we expected. They looked at us weird and said, yeah, of course we test our software. What are you talking about? And he was trying to, again, try to lead them down a path of a technology that we were building to help them test their software. But that's not how you open up the session. Hey, do you test your software? See what I mean? So, and I just cringed. It's like, that's not what we do. So you can do it right and you can do it wrong. You have to be, it does take practice and experience to be comfortable in a situation like this. You will get, in some interviews, for example, if you have a customer that you've worked with for a while and let's say they don't like something in the product you've got out there in the marketplace, part of the interview might be listening to them yell at you about what they don't like about your product or what really sucks about your product. You got to deal with that without getting too overwhelmed. These are the things that come with real, actually getting out there and really doing it. So interviewing, not as easy, as cheerful always as these two guys in the little cartoon here. Okay, let's move on. Brainstorming is another, it's a way of getting a lot of information quickly. What you tend to do here is get some people that have a general interest in the problem in a room, and you essentially just go around the room and ask for input, ideas. And I like what Alex Osborne says here. This is really true. It's easier to tone down a wild idea than to think up of a new one. So in other words, anything goes. Wild ideas, things that may seem impossible, anything goes. You can't criticize. If someone says, I think I should send this computer program or this laptop application to the next Mars mission, anything goes. You don't laugh, you don't criticize. It could be wild, crazy, impractical. Jot it down, and then after we get all the data, then you go through and evaluate it, and the ones that make sense, you go off and pursue. When I was in the defense business here at TI, actually it was Raytheon at the time, we had an idea of literally taking a Linux-based system and putting it in an aircraft, a surveillance aircraft, because the system was great at analyzing data, but it only did it on the ground in a lab. We had an idea of being able to take the same system and doing it in real time in an aircraft during surveillance operations. And before we went into this brainstorming session, I literally, no joke, I had another manager, when I explained the idea, laugh at me and tell me how crazy it was. It'll never work. 2.5 years later, we had that in the aircraft flying in a production system. So you never know. You never know. And so you want to throw out ideas, and something may stick. Something might not be as impractical as you think once you kind of get into it. So now the downside to that is some people can dominate the discussion. This is just a sample agenda that I used the last time I did this. Quick introductory session on the topic. You have to always remind people the rules, because there's always going to be someone that likes to criticize or tell you why it can't be done. So you always have to kind of go over the rules. And then do a little warm-up activity, mainly just start simple, then get into some brainstorming sessions. Because it can be kind of intense, you want to break every, I think I probably did it every half hour. But you don't want to go for a long period of time without taking a break. Eventually, after we got the data, you have to eventually whittle it down and decide on a consensus what you want to pursue. Then, if you have people in from out of sight, different sites, you want to thank them and send them a nice little thank you letter or whatever. And then I always want to get feedback too. So you run it like a meeting, but you have you don't have to necessarily even prepare for this. People don't have to go off and research and come with well-prepared notes. It's just show up. We're gonna get your ideas. So this is actually used quite often in the industry. Now there's another slightly more formal approach. It's called a JAD, Joint Application Design. It's similar to brainstorming, but normally it goes on for several days. Now with this one, again, like it says there, it's more structured, so you have it's not just literally you throw anything out there, anybody can comment. It's more of a collaboration between, it says here analysts. When you see analysts, think requirements engineer, business analyst, and the customer, and it is facilitated. We actually would bring in, there are people that have full-time jobs as facilitators, so all they do and what they're really good at is facilitating meetings and keeping everybody from yelling at each other and keep it structured and on track. These guys are experts at that. So we've actually hired professional facilitators at times to help us with this. They come in and help you run the meeting. Now the other key thing, whereas in brainstorming you don't actually produce any artifacts, in this anywhere from 2 to 3 days, it could even go a full week, you actually produce work products, usually in the form of some kind of model, which coincidentally every one of these models here we're going to be talking about in this class. We'll be developing every one of these models. I think you're on your project you'll be doing this too. But there's actually work products that come out of here, usually in the form of diagrams and models to help explain the idea in a little bit more detail. And but you still have a team approach to ultimately decide what makes sense to go forward with in requirements. So now the key thing here, you have whereas in brainstorming you won't have the customer per se, in these you will. So you're getting much more of the voice of the customer, and you're using that to actually say, okay, let's go to the whiteboard and jot this down. Let's see what it looks like. Help me draw this thing. User interface prototypes can be also on this work products. That happens a lot here. So it's I think of it as a structured, longer elicitation where the output is not just these work products, but also, you would hope, is a set of requirements that you can write down and begin your specification process. Now, as we go into also other areas of trying to capture what the customer has to say about this product we're trying to build for them, there's a lot of voices we can capture from the customer. We've talked about a few of these already, like constraints and quality attributes and functional requirements. We'll talk about some of these others today. Again, a lot of it is trying to elicit not just from one customer or one person that represents a customer, but possibly from various different types of customers if you have many. For example, in the digital networking group where I am, we have customers that build all kinds of products from printers to large cell phone base stations on big poles out in the field. I mean, so customers, there's a lot of different customers, each with their own voice, if you will. I put this in here just to give you an example of a JAD I participated in. I'm on the advisory board of the Embedded Systems Conference, and we used to have a JAD every year, and this JAD was run kind of the same way I just told you. Now this one was actually interesting. It was not so much building a software product. This JAD was actually building a product that was a software conference. So think of a software conference that you would go to, you'd register for and go to, take classes, as the product we were building. I am on that advisory board. So this one is one example of how a JAD gets done. So advisory board, we published an agenda, just like I said. Introductory topics, just like I mentioned earlier. Then you get into it. We started off talking about goals. Then we had the breakout where we did the actual JAD. One of the things about doing a JAD that gets the right people involved is to feed them. That's why we had a nice dinner at a very nice steakhouse. That's another good way of getting the right participants, is to feed them. It's amazing how effective that is. Either feed them or give them a t-shirt. We tend to get a lot of participation. So we did the JAD, that was day one. I think this was day two. Again, we did the closing remarks. We shared all of our ideas right there. We spent really a large part of the morning sharing a lot of the ideas we talked about earlier. And as you can see here, the list of participants was a large cross-sectional group of people that were going to contribute or contributed the customer voice to this JAD. And so this lasted 2 days. I think it was 2 days. Oh, 3 days. And you can do a JAD for anything. This is just, and then pre-work. This was a list of the questions. I won't go through all this. By the way, this whole list was our customer. That was a customer involvement. So we had industry, this is us, and we had all the tech insights was our customer. So the whole big room full of people, and they gave us pre-work. Hey, don't just show up without any ideas. Here, we want you to answer all of these questions and come prepared to discuss them. So it's actually work. But at the end of it, what we got was a new set of requirements for this conference. One of the biggest requirements, or biggest successes was, has anybody been to the Embedded Systems Conference at all? Okay, it's in San Jose every spring. And one of the big things just as one example, big requirements that came out of one of our recent JADs was to offer a new course called Build Your Own Embedded System, where we actually gave every enrollee a little development board, and then we taught them courses of how to build an application on top of that development board. It became one of the most successful course offerings that we've ever had. That all came out of that JAD. It was discussion about what we could do to improve the product, and so a lot of that. So it's very effective when you get the right group of people focused intensely for a couple days on the problem. A lot of good requirements come out of that. So just one example of that. There's some other artifact-driven elicitation techniques. Again, a few that you see a lot of. Background studies, where you literally go out and you study the customer or the customer environment. Networking, or like automotive, I'll pick another example. There's a lot of background study in different types of automobile safety-related concerns. You see cars now having more and more radar-type safety requirements. You see this on the commercials all the time, right? That starts with background studies of where that industry is going. So we will go sometimes with our customer, do some R&D, do some background research as to where the industry is going, and that forms a good input to requirements. Same with just data collection of that same industry. We send out questionnaires once a year for our. We have a product that we call Code Warrior. It's a software development tool suite for embedded developers. Every year we send out a questionnaire, and we sell probably 10,000 of them yearly. And we send out a questionnaire to all the people that buy it. We say, tell us about the usability, the effectiveness, et cetera, et cetera, et cetera. And based on that input, we feed some of that into our next release. In other words, we feed that into the next requirements session for the next release. So questionnaires can be effective as well. Grids, card sort, concept-driven acquisition, card sorting, affinity diagrams, being able to just do basic things like take, does anybody do agile development? So you do some of that affinity, card sorting, you put the little stickies on the wall and with ideas, and then you can group them into different categories, and those categories can form or can be great input to requirements for your process. But it's kind of a cross between some brainstorming and a JAD, but you form ideas, you group them, and then use that as and then you distill that down to some key requirements. Those are effective. And then we're going to talk, I've got some slides on storyboards and scenarios. Storyboards came from the movie industry. A great way of showing a story of how you expect the customer to use your product in an environment. I'll talk about that, and same with scenarios, use case scenarios. We'll also talk about misuse scenarios as well. Speaking of this questionnaire, you can find these all over the place. Anytime you're developing a product with a user interface, if you want to get some good feedback from customers on what they like and dislike about your user interface, there are all kinds of usability. For example, remember usability was a non-functional requirement. Surveys that you can do, you can either build your own, you can get someone to do it for you. It used to be that to get it done properly, you'd have to pay a lot of money to have someone design one for you. Now you can actually find a lot of this online. So you can probably do it by yourself, and you can actually ask the customer, what do they think about the non-functional requirements that are important to you? Is it learnability? Maybe that's really important for your tool. Or sometimes even relearnability. If you have a product like a computer-aided design tool where an engineer will use it for his design, and then not use it for 10 months till his next design? How quickly can they relearn? Things like that. You can ask them questions about that. So this survey, I just threw this in here. You can see, reaction, terminology, learning. You can ask them anything you like. This is a typical Likert type scale. This one goes from 0 to 9, 0 to 5, 0 to 7. Likert-based scales work effectively too. And then you can set a goal that if there's any rating that's lower, on average, lower than some threshold, you can say that is a problem. We have to go improve in that area. And that can be a requirement into your next release. So anyway, I threw this out here just to show you. I found this online, pretty easy to do, but survey is very effective at getting information from users in a relatively cheap, inexpensive way. We make every user that buys our product give us their email address, and then we shotgun out various emails to them, including occasionally a questionnaire. Hey, tell us how you liked it. We're always trying to improve our product. Tell us what you like to see in the product that's not there. And like back here, we always give them the opportunity to write in what they like and dislike, what they'd like to see next. And this is a great way of getting good requirements, especially if you can't go out and visit a customer. Your customers are from all over the world. You're not going to be able to fly all over the world all the time, so just put a questionnaire out. Okay. How many of you are familiar with use cases and use case scenarios? Usually a bunch of people are. Okay, a few hands. Okay, not as many. That's fine. We're going to go through it. This is use cases and use case scenarios actually started a long time ago. It actually started kind of back in the object-oriented days in the late 80s, early 90s. This Swedish guy named Ivar Jakobsen has been given credit for kind of he's kind of the use case guy. Prior to that, there were some other guys like John Musa who had similar types of things called operational profiles, which is kind of like a use case scenario, but a little bit differently. He came from AT&T, and he believed that the best way of testing a system was to define different operational profiles for the system and then test it that way. The use case thing extends that concept a little bit, but both those guys were on to something. And it's evolved over the years, and now it doesn't have to be used with just object-oriented type computing. You see, I use this. This is one of our primary ways, not only of eliciting requirements, but also for testing requirements. I'll give you an example of that too, as we're dealing with a little crisis situation right now, so I'll tell you about that. Let's go over this. So again, a use case, first of all, it's meant to capture the functional, and that's important, the functional requirements of a system. And you're supposed to do it from different perspectives of the users. We're going to call these actors, which is a more general term in a second, and how they actually use your system to get something done. We're going to document that in enough detail that we'll be able to describe the requirements and even some of the user interface requirements for the system we're trying to build. Eventually, I'll show you a template. We're going to think about the idea of writing a textual narrative, or sometimes what I call a short story, that describes this interaction of a user using your system. So for example, if you're building a new application for a cell phone, it might be describing in a relatively less than one page the type of person that is actually using, how they're going to use the application to get something done. Walk them through step by step. What does the user do? What does the system do? What does the user do? Then what does the system do? I'll show you an example of that. But that's kind of the idea of what we're trying to do here, is functional from a user's perspective, the back and forth interactions, writing a short story, if you will. I'll talk about that again in a second. So we're going to try to visualize what actors, again, are involved. Now, an actor here, remember when I talked about stakeholders earlier? A stakeholder, I call them indirect and direct stakeholders. A direct stakeholder was a person that's actually kind of using the system. An indirect stakeholder was someone that may not use the system but may benefit from the system. Well, actors are those, plus they can be other, I'll call them inanimate things, like they can be a machine, another system. It doesn't have to be a person. An actor can be a thing. I'll show you, again, some examples of this. So actors are people or things that interact with your system. Now, these functional requirements go into your requirement specification, eventually get implemented by design. You're not trying to design the system. You're trying to, again, specify the what. A few people had a little bit of a challenge on the homework asking about this whole idea of design-oriented requirements. What that means is when you start writing a requirement that tells a designer how to do it, okay, as opposed to what to do and let the designer decide how to do it, that's the difference. A requirement is supposed to be about what to do, and then the design guys will tell you how they're going to do it. Now, sometimes there's a little bit of overlap there. It's not exactly a nice, clean interface, but that's the idea. Okay, so we'll talk, I'll show you some more about that. Now, non-functional or qualitative, these are the quality requirements, usability, performance. These are not depicted in use cases. So this is purely for functional requirements, okay? Now, later on, I'll talk about a term that sounds familiar. It's called user stories. It's out of the Agile world, but we're not going to talk about that now. This is going to be use cases, which is the more traditional approach for specifying functional requirements. So the general approach to this, if you were going to implement this in a process, is kind of shown here. First of all, figure out who's going to use the system directly, directly interact with it. And what I'm going to do here is I'm going to use a simple example, because you've all probably had this example at one point or another, but that's okay. I have to pick a simple example. So of course I'm going to use the famous ATM machine, right? We always talk about this, right? Who's talked about an ATM machine in the past? Well, anyway, we have an ATM machine. So when it says there, step one, identify who will use the system directly. Pick a person that would use an ATM machine directly. Well, it'd be a customer, right? All right. So if you follow these steps, it would say, okay, pick one of those actors. Now, with a use case, the first step we're going to do in this class is we're going to develop what's called a use case diagram, and it consists of 4 parts. The first part is this. It's the boundary. Why is it important to draw a box? And because you'd be surprised, especially with complicated systems, sometimes what you're trying to describe, it's not obvious what you're doing and what someone else might be doing. That interface sometimes gets hazy. So it's always good to draw a box that says, okay, everything in this box I'm doing. Okay. Now that's called a system boundary. So this is pretty easy. That's step one. This is just a system boundary. Step one. Now step two, if you just go back to this little process here in the notes, pick an actor. Now there'll be several actors. The first one I just heard was a customer, and I'm going to draw, again, the traditional representation for the use case diagram from many years ago. It's changed over the years, but step two is to define all the actors. Now there'll be many, but we're going to start with simple one. You always want to label your actors, so I'll call this one customer. So you pick one of those. Now you want to define what the actor wants to do with the system, and that ultimately becomes a use case. Before we get to that, let me say that again. We mentioned that actors can be people or they can be things, right? So in this ATM machine, let's build out the actors first. I think it's important to think about this. So obviously we have actors that may want to do some things with our automated teller machine. Are there any other types of, let's say types of people that may want to interact with this machine, this ATM machine? Oh, like the maintenance guy? Yeah. Or banker? You say banker? Yeah, okay, let's say banker. So a banker may want to do some maintenance to the system, like replacing money or whatever, right? I'll put a maintenance guy down here too, because sometimes these guys have to come in and maybe gather diagnostics data or whatever. How about some non-people actors, other systems that may interact with this ATM machine? Let's define this ATM machine as what you might see in the hallway, that you go up and you put your card into, right? Are there any other things that it needs to interact with? Money? But more generally, before you can use an ATM machine, you have to have an account where? At a bank, right? Let's just call it a bank for now. So this is an example of an inanimate thing, a bank actor. Think of a bank as a system, right? It may get involved in this ATM machine, right? Let's leave it at that. So that's step two. We have a boundary, we have actors. People or things that could interact with this ATM system. Okay, now, what's a use case? Let's talk about that next. A use case. Well, it's kind of like what the term means. It's a way in which one or more of these actors, or sometimes more than one actor, have to collaborate to get something done. It's how one or more of these actors will realize some benefit from the system, okay? Let me state it a different way. If you were to describe, let's say you got into an elevator right out here and you're going up to the 4th floor, okay? That's going to take about 12 to 15 seconds to go up to the 4th floor, okay? And let's say your boss walks into the elevator and the door shuts, and this is your opportunity to explain to the boss why you want him to fund your ATM machine. Okay, you're going to build a software product, an ATM machine, and you have to convince him. And so you're going to tell him the key benefits this ATM machine has, right? The key things, if your boss says to you, why should I spend money on your ATM machine? What is it going to do? And you have 15 seconds to explain it to him. Obviously, you can't go into detail, right? You can't go into a lot of details about what it's going to do. You can't talk about the details of the cryptography that you're going to use to validate user, blah, blah, blah. It's going to be the high-level value functions, right? So in 15 seconds, if I had to describe the key functions of this ATM machine, what might you tell your boss going up on that elevator? Okay, so you can do withdraw money. You can do deposit money. Anything else?
Fund transfer.
Okay, you can do fund transfers. Balance. Okay, balance.
Reduce the number of employees.
What was that last one?
Reduce the number of employees.
Reduce manpower. Yeah. Okay, now those are all good from you as you were coming from the perspective of a customer, right? Now let's say instead of you getting into the elevator, let's say you got into the elevator along with a banker, and the banker's like, after you said these things, right before the elevator doors opens, the banker said, well, hold on, we also need to be able to, I'll call it manage the money, right? And if this maintenance guy also got into the elevator with you, right, then you go, oh, hang on a second. We also are going to provide some innovative ways of just maintaining the system, whatever we decide to do there. Okay, but you get the point, right? A use case is a high-level value proposition that the system is going to offer. Think of it that way. A high-level capability, functional capability that the system is going to offer to one or more actors, okay? So that's part 3, is defining the use cases. I think I have some questions to help you decide how to develop a use case. And there's one more part, and that is something called the relationship. The relationship ties together which actors are involved in which use case, okay? This is important because, again, there's collaboration between these different actors, and you have to be able to show, at least at a high level, which actors participate in which of these use cases. For example, if we're going to withdraw cash, well, obviously the customer is going to be involved in that, but also the bank is too, right? Because you have to do some things like check for balance and things like this. And you can probably do the same thing with deposit money, right? Even fund transfers. That's a customer perspective, and even do a balance, something like that. But a banker, or let's say a maintenance guy might be the only guy that interacts with that use case, right? And depending on the kind of maintenance of the system, I mean, it may or may not interface with the bank. We'll have to decide that. And then these other ones like manage money, the banker might get involved in managing money. So basically what you do is you connect, you can use simple lines, which actors participate in each of these use cases, like this, and that part 4, the relationship, that builds out the use case diagram. Okay, so what's a use case diagram? You draw the boundary, okay? You develop the actors, you develop the use cases, and you develop the relationships. And if you have those 4 things, you've built the use case diagram. Okay? Sorry, it's a little bit messy, but I'll try to get better. But that's, and by the way, this is in your notes, so you don't have to take notes on this. You'll be able to see it here in a second. So that's kind of what you would do. Now, in reality, in the real world, you can get into much, much larger systems. One of my students a few years ago who works at, he was developing some requirements for the American Airlines reservation system. And he had use case diagrams that had hundreds of use cases on it that would literally fill the wall, big paper spreading over the walls. So this isn't, sometimes this gets to be very, very large exercise that can take, many days to complete with the right people in the room. So this is a simple one. You can see here the general structure of it. Now, okay, so far so good? All right, now let me ask you a question. Let's take withdraw cash, okay? Now, when we walk up to an ATM machine and we want to withdraw cash, there's different ways we can withdraw cash, right? Tell me a couple different ways we can withdraw cash. You can withdraw it from your checking account, savings. You can probably do some kind of debit or credit thing. You can do the fast cash option where you just hit give me $100, boom. So there's like different ways of doing withdraw cash, right? So, and each of these use cases could have different paths through it, right? So all of these will provide you a way of withdrawing cash, but there's different ways of doing it. We now want to describe that in a little bit more detail, okay? So now we have to go a little bit further. So if you go back to let's go back to the laptop real quick. We build these actors, we build the use cases. Once we decide what these actors want to do with the system, each actor may want to do different things with the system. I just showed you an example of that. Now, for each use case, you want to determine specifically what happens as this actor performs what he wants to do with that use case, like withdraw cash. And now what we're going to do is we're going to go off, we're going to describe that in terms of what's called a basic course or basic course of action. Now, what this means is when I withdraw cash, have you ever walked up to an ATM machine and you tried to withdraw cash and something went wrong? Okay, what went wrong?
You're out of cash.
Okay, so the bank was out of cash, no more cash. Okay, any other problems?
They didn't update my account due to weekends.
They didn't update your account?
They didn't update my account due to weekends. Like on weekend, I deposited a check and it didn't show.
Okay, so you didn't have money in your account. They didn't deposit it, so you went out to the balance was zero, or whatever. Your balance was low, and you tried to withdraw cash, and you didn't have the balance. Okay? Anything else? Yep. Excuse me. Incorrect PIN. Yep. the machine can go down, the network connection. So there's all kinds of things that can go wrong, right? Okay, we're going to get to that, but for now, when we talk about the basic course, think of that as the everything works right scenario. So the basic course means the first thing I'm going to talk about is what happens when everything goes right. There's no problems. I have cash, I've got, I type in my PIN, I use the right card, et cetera, et cetera. So we have to go off and look at this now from a basic course of events. Now the way I like to do it is actually might be a little bit more efficient. Let me go back here. So there's a little use case I built for the bank. You guys pretty much hit on it. Again, you can have many more use cases. Like for example, let's say your ATM machine. Well, actually, what's not shown in these use cases? I tend to get this a lot, so I'll throw it out there. You don't see use cases that say things like login, right? Why is that? Because that's not considered a real value function that the system offers. Now, if you'd said to your boss in that elevator, that's right, however, my ATM machine is going to have a biometric login mechanism that is different than any other system out there, and so, and it is a real value function, then you can come in here and say something like, biometric login, as opposed to the standard, swipe your card, or voice activation or something like that. So, but otherwise, you don't want to put trivial things in here. Again, they're high-level value propositions. So anyway, you could have more. I showed you more in this other example. Okay, now this template, I was going to draw this on this sheet, and I decided, what if I just walk you through it, which is probably going to be easier because my handwriting is so bad. But this template I find to be, pretty good. There's a lot of them out there, but this one kind of goes through some of the key information that you normally would like to see, and I'll explain as we go through this. Some of these are self-explanatory, like the intent. What are you trying to accomplish with this? The scope. This provides a little bit more information as to what area of capability this use case is going to cover. Now this level, I didn't talk about it, but and don't worry about it, but I can go into, just say a few words about this. You can generalize these use cases to very, very high levels, and that's called the business level, where you talk about very high level business capabilities, like Freescale has a design engineering use case, and a software engineering use case, and a supply chain management use case, and so very high level business use cases. Then you can get down to system level use cases like this product, like this ATM machine, will do these things. And you can even go down to a component. This financial software component can do these different types of financial services. So you can have these at different levels. Now in some companies, they'll start out with business level use cases, then map those down to system level and component level. What I do in my group is we pretty much stay right in the middle, but each company is different depending on what they want to do. One thing that's missing here that is important is an ID, because normally you'll want to trace this to a set of requirements, and so normally an ID is necessary. In other words, you'll see this a lot. You'll see a table, and I've got it somewhere in the notes, where you'll have things like you'll have, let's say, your requirements, R1, R2, R3, R4, etc., and your use cases, use case 1, use case 2, and you'll be able to check off which requirements map to which use cases. This is a very small table. This can be very large, Excel, a spreadsheet, or a requirements management tool. So you always want to be able to trace use cases to requirements, because if one of those use cases changes, you'll be able to get a quick idea of which requirements you have to go back and change as well. Okay. Anyway, back to this template. The reason author is important, you always want to know who to contact in case you have a question. This is just configuration management, change history. If you use a requirements management tool, they'll do some of this change control for you, but it's always good to know when it was last updated. Status, some of these use case scenarios will be done, some will be under review, being analyzed, so I always want to know the status. Now let's get into some of the important stuff. So actors, primary and secondary actors, sometimes these are, believe it or not, called supporting actors. I know it's a movie thing, but anyway, primary and secondary is okay. The primary actor is the one who's is the actor that's is essentially getting, think of it as getting the most value out of the use case, and the secondary or supporting actors are the ones that, again, are helping support what the other actor really wants to get done. So in withdraw cash, who do you think, who do you think would be the primary actor? The customer. And then the secondary actor would be the bank. They're supporting this idea of the customer withdrawing cash. So now, here's one thing I'm going to check, because it is kind of important that you have a good understanding of who's involved. When you put down a primary and secondary actor, what I'm going to do is I'm going to, let's say this is for withdraw cash. If I go back to your use case diagram and I go to withdraw cash, I'm going to see that there's two actors involved in this use case. There's the customer and there's the bank. And then I'm going to go back to this and I'm going to look for, see whether they fit in here. Okay, if you don't have them, or if you have different actors, it tells me you haven't really done a good job at understanding the relationships between the actors and the use cases here. So if you have customer and bank here, I'll look for, customer here and bank here, right? Make sense? Okay. Preconditions. Precondition says, okay, here's what a precondition does. You're going to tell a story about how a customer interacts with this system to get money, right? And we're going to talk about the steps to do that. Now, when I start telling this story, okay, I can make some assumptions about where the story starts. Okay, so for example, I can say, my story can start when the customer walks up to the ATM machine. I can start my story assuming that the customer has already logged into the system, right? I don't always have to tell the story assuming that, or starting with the customer walking up to the ATM machine. I can start anywhere I want, right? It's almost like opening a book to any chapter, right? And you can start reading from that place in the book, but you have to know where you started, and you have to know all the context. So if I want to start from after the user is already logged in, I can do that, okay? But I have to be specific about it. I'm going to start this story assuming that the state of the system is of a certain type. In other words, I'm going to assume that when this customer walks up to the ATM machine, that there's actually cash in the ATM machine. Okay? I'm going to assume that. Okay? I'm going to assume that the ATM machine is plugged in and it has network connectivity, right? Because if my story is going to be told correctly, I've got to assume that these things are there, right? So a precondition specifies that. It says here, what we expect is already the state of the world. That means, in this case, that means the state of the ATM machine. So in a precondition, you would put down things like, I'm going to assume that the ATM machine is plugged in, it's got network connectivity, it's at the main splash screen, right? It's sitting there, waiting for someone to come up. It has cash. That might not even be good enough. You may want to say, you want to assume that the ATM machine has $2,000 in cash in it. You may want to assume that the ATM machine has enough receipt paper that I can actually print out a receipt, and anything else you deem to be important. Okay? Is there anybody here that has ever tested a software system? Nobody's ever tested the software? You've never tested your software? Really? Okay. Well, if you do test your software, what you normally do before you run your test is, what do? You initialize your system. You put your system into some known state, right? Because the software system is stochastic, which means if you want to get a test result out, you have to put it into a known state and then stimulate it to get an expected output, right? So you would have to put your system into a known state if you're a tester. It's the same concept with a precondition. You have to assume your system is in a predetermined state before you start telling your story. So we can assume that this system is in this state of, I'm going to assume that it's in this, the precondition is the primary actor is standing in front of the ATM machine. The ATM machine is on, it's got $1,000, it's connected to the bank, and it's at the intro screen, okay, as preconditions. Is there anything else you'd like to add, or is that good enough? Is that good enough for now? Okay, so that's the precondition. Okay, you could, let's ignore the dynamic preconditions for a moment. There's some other assumptions you may want to make about the system. You may want to assume, for example, if you've got an ATM machine that's, let's say it's in a subway, down in a subway system, you may want to assume that there's adequate lighting so someone can actually see the ATM machine, things like, you may want to make other assumptions like this. Okay, I want to talk about, I want to substitute in this template, I want to go through the next, let me draw this on this screen here. I want to rename this a little bit. Once you get past the preconditions, okay, I'll get back to this template in a minute. The next thing you really want to focus on is, which is your story. And the way I'm going to describe this is the following. I'm going to call it the typical course of events. Now, what does that mean? Remember how we said we wanted to take the approach that nothing fails, the perfect world scenario, right? You know, there's cash, you type in your PIN correctly, all this. That's what the typical course of events means. It means, you know, typically, how do you expect the system to operate? Now, the way I like to do this is I like to break this up by actor and system. You can do it a lot of different ways. I've done it in Excel this way. It works pretty good. PowerPoint tables work good. And I just like to do it this way because it has some other benefits I'll talk about in a second. So once you start telling your story, the first thing you want to do, or you want to remember, is that a story always starts with the actor doing something first. A story does not start with the system doing something. So it always starts with the actor, you know, is going to do something. He does something to start the use case scenario. This is, by the way, typical course events. This is where we're going to talk about use case scenario now. Okay. So the actor does something. What is the actor going to do? If I'm going to assume in my preconditions that the actor is standing in front of the ATM machine, what should the actor do first? Put his card in, right? So that could be what this is. So the actor, you know, you could say inserts card, okay? Now, I'm going to skip down to this, put the 2 down here. Now, when the actor puts his card in, you know, then the system's going to do something, right? What's the system going to do first? Yeah, it's probably going to, and by the way, I'm probably going to skip some steps here, but you're going to get the picture, so just, you know, kind of work with me on this. So it's going to verify the card, okay? In other words, is it the right card you inserted? You didn't insert, you know, a MasterCard or whatever. And then it's going to prompt for PIN. Does that make sense? Okay. Back over here. So the actor now can enter PIN. Okay, now let me explain 2 important things here. One is, I could have put down here, the actor types in the PIN, right? I could have put that, right? And most ATM machines, that's exactly what someone would do is, type in their PIN, right? But what's that doing? It's kind of implying that the way you're going to implement, the system is you're going to have to have a keypad. What if the entering the PIN was verbal? What if it was touchscreen? What if it was the keypad? There's a lot of different options for entering the PIN, right? So sometimes what you do when you develop these scenarios is you want to make them what are called agnostic. What that means is you don't drive implementation details into you let someone else figure that out. That's why I put just enter the PIN. You're still getting the story across, but you're not driving implementation details. Now the next thing about why this is, you see I'm leaving these things blank. You see how it flows kind of like this? Well, another interesting thing you can do here, especially with systems where you have generally when you have a user interacting with a system like this, you've got some type of a user interface. And what you can do here is you can begin to annotate this scenario with a user interface prototype. So for example, when the actor walks up to the ATM machine is going to be probably at the introduction screen, right? So over here, you could actually sketch or draw, some kind of a interface that you think the ATM will look like to welcome the user, whatever that is. You make it up, okay? What's that? No, a prototype, you're not specifying implementation details necessarily. You're not specifying widgets and stuff like that. As we'll talk about later, a prototype is actually a good way of getting requirements for a user interface. You don't have to go as far as designing widgets into it. So it's a good point, but I'm going to talk about prototyping later. Low fidelity prototyping can actually be a good requirements elicitation technique. So but it's a good point, but I'll get back to that a little bit later. Right now we're just trying to show how the system could flow during this use case. A lot of requirements documents where people are trying to show what an interface would look like are done very poorly. They're just page after page of screenshot, 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 but nobody really knows the context of how you would use it. This helps you with that, okay? So like over here, after the user swipes the card, okay, inserts the card, then over here, you can have, again, it's a low fidelity hand sketch that says, it can have maybe some, and over here it says, enter PIN, and maybe it's got some kind of thing there. And then over here, when you enter the PIN, you can show what it would look like after. So in other words, you can actually design. I say design. You can actually show a low fidelity prototype as you're walking through this use case scenario, and you can see how a user might expect the interface to change as it goes through this typical course of events. Again, the reason this is useful is because user interfaces, more than any other form of requirements we're going to look at, they're very difficult to get right. They're very difficult to verbalize, like, in other words, to write English languages to describe what an interface. Can you imagine trying to write natural language to describe all your interfaces? How hard that would be? Just draw a picture. And that's what. So when you do this, when you throw in this little user interface prototype into this mix and show how it transitions, well, this is actually a concept of a storyboard, which I'll talk about, and I've got pictures of later on, but that's actually what we're trying to do here, this form a little storyboard, okay? Right now, so the actor enters the PIN. If I were to follow this whole thing, assuming it gets it right, then the system is going to do what? The system will do something like prompt for transaction or something like that. And you're probably figuring this out. Over here, the customer, you want to always say customer, whatever the actor name is. The customer selects withdraw cash, right? Then over here, the system could say, do you want to do that from savings, checking, etc., right? Again, all along you're kind of drawing in what you think the interface might look like. Just showing how it transitions between the different steps. And you're going to go all the way down through this until what? So you'll select withdraw from savings. It's going to ask you how much. You get the picture, right? This can go on off into another page, but I think I don't need to go through that. You kind of get the idea of mechanically what we're trying to do here, right? So what have I shown you here? Step by step, in summary. So step by step, typical course of events. You start with the actor doing something, not the system. Generally, it follows a back and forth. It would look odd to me if the scenario was actor does this, actor does this, actor does this, actor does this, system does this. If it's that kind of thing, it would look a little bit odd to me if the system never responded at all to all these different inputs. So just be mindful of that. Kind of when you're done with it, just read it and convince yourself that it actually works right. Sometimes just reviewing it with other people. I did this once with a marketing guy who didn't know anything about use cases. And once we walked through one of these, his eyes were opened. He discovered so many new things he hadn't thought about just by talking their way through this. It was pretty eye-opening for him. But now eventually you're going to end up down here at the bottom where, blah, 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 you're doing all this stuff. And you're going to finally, the system's going to say, do you want a receipt? You say yes. The system's going to spit out a receipt. Do you want another transaction? You're going to say no, and it's going to end up back, at some welcome screen, right? So maybe all the way down here at step 21, the system updates, maybe it updates customer info and goes to the welcome screen, okay, or something like that. I've got an example in the notes. All right. Now that's called a typical course of events. Now, I like it this way. You'll see some other forms and templates. Every book, every article has a different way of expressing this. You can pick any one you're comfortable with as long as you're consistent. I like this one because it gives you a lot of perspectives at the same time. Now this, I've seen use cases go on. Again, these are relatively abstract. 25, 30 steps max. I think in this class it'll probably be even less. Like on a homework or an exam, you might have one that may do 8 or 10 steps. Nothing, they won't go on. Remember, like I said earlier, it's supposed to be a short story. The guideline is a whole use case scenario should fit on one page. Use that as a guideline. If it's more than that, you might be getting into a little bit too much detail, or it's a very complicated process you're going through. Again, guideline, not rule, just the guideline, okay? Yeah, it's kind of a stimulus response. Yeah, you can do it that way. In a system like this where you have this user interface that we're dealing with, not all of these use case diagrams will deal with a user interface, but a user interface is by definition is an event-driven system, so very stimulus response oriented. So in this case, yes. Now in other cases where you might be describing a use case when you're talking to maybe a low-level piece of hardware or a motor or something, it may be a little bit different, but yeah, in this case, yeah, definitely it's kind of a stimulus response oriented thing. Okay, now when you're done telling the story, you have to tell the reader where you're leaving him. You can't just end the book in the middle of the good guy chasing the bad guy and then the book ends and you never know what happened, right? So you got to describe, okay, when you finish telling the story, what's the state of the system? Again, if you're a tester, which I'm surprised there's no testers in here. Actually, there is. You're just not raising your hands. But if you're doing testing, this would be, when you finish running your test, what's the state of the system after you ran the test? Think of that almost like a post condition. So post condition in this ATM, little ATM example, would be the state of the ATM after you finish telling the story. So you finish telling the story where you told the ATM machine, I don't want another transaction. The ATM machine said, thank you, goodbye. And then it goes back to the welcome screen, right? So now you have to say, okay, I'm going to describe the state of that system as I left it. So the user's walked away. That system has changed a little bit, right? It's changed a little bit. In some ways it's stayed the same. So describe the state of that system at the end of that story. Well, it's back at the welcome screen. You can say that. The ATM machine is back at the welcome screen waiting for the next customer. What else can we say about that system that's changed?
Money gets less.
There's less money in the ATM machine, right? So the money in the ATM machine is X minus $100, whatever okay. What else has changed? You can make something. You can say the printer cartridge, is a little bit less, or whatever. Yeah, but you could. I mean, if it's important to the story, like for example, if software is monitoring or doing diagnostics checks on that stuff, you can say, yeah, there's some change in that state if you want to do that. Yeah. What can we say about the user's bank account? So, yeah, well, the bank account. So the machine itself has less actual physical money. But the bank account is also less by $100, right? You have to say that too. And you may even want to say that if one of the maintenance use cases is diagnostics, you may also want to say that some special diagnostics data has been logged about the system. But you want to describe that ending state, right? So think about those subtle things that would help describe the state of the system after you finish telling your story, right? Does that make sense? Okay. Now, let's see here. I want to. I'm going to get back. I'm going to deviate a little bit from this template, so bear with me. I just told the story. The post conditions generally would come at the end of the story, so you can put the post conditions at the end of the story. So, right down here. We tell the use cases, or we tell the preconditions up here, and we tell our story, and then down here you can write the post conditions if you want to. Okay. Actually, let me go to another slide because there's a few other things I want you to do. Okay, so we put the post conditions. Again, it's all based on the state of the system, but it's after you tell the story. Okay. All right, now that was good for the perfect world scenario, right? Everything went right, okay? But as we all know, especially when you have a human in the loop, things don't always go right in this type of system, right? So there's always what we call exceptions. Now, in some cases, people will bundle this. I'm going to put a slash. We'll bundle this under the term alternative flows, and I'll explain the difference in a second. But let's start with exceptions because it's more clear to the point. Exceptions are obviously things that can go wrong, right? So, and we talked about some of these exceptions earlier, right? We could do things like, insert the wrong card. We can, type in the wrong PIN. We said there could be a network error. We said there could be no cache. We said there could be low balance, etc. Right? All these are things that could possibly go wrong in the system, right? And so, again, since we're coming up with functional requirements, we do have to talk about these alternative flows as well, because there are requirements on the system. There are requirements, for example, a security requirement would be, if you type in the wrong PIN, what would be, what should the system respond with? Well, maybe the system responds with try again, but if you get it wrong twice, I'm going to keep your card. That's a security requirement or something else. So if you come over here and you say, okay, let's take this first one, wrong card, how how would you make that work? Well, a wrong card would be, okay, I do step 1, and then over here, instead of verify card prompt for PIN, I would say verify card output error message, right? Or something like that, right? So over here, you can have a little short story for wrong card. I mean, it could look the same. It could be actor, system, but then you can say, okay, actor inserts the card, and then over here the system checks the card and responds with an error or whatever you want to do. It's up to you. You're eliciting the requirements here, okay? And you can even phrase it appropriately. If this was a very long use case that went on for 20 or 30 steps, you don't have to come up with a whole new one. You can just say, hey, you know what, at step, let's take this one. Let's take wrong PIN, okay? Well, where does wrong PIN start to become a problem in this use case? Well, it kind of becomes a problem right here, right? So you could say, when you're describing the wrong PIN exception, you can say, okay, in the withdraw cash scenario, at step 3, so you don't have to repeat steps 1. At step 3, the actor enters a wrong PIN, and then the system responds with wrong PIN, try again, and then prompts with the, gives you the PIN entry thing again. And you can go back and forth from there, right? And then down here, where this is an interesting one. When would you expect the system to detect a network error? Again, think about it. This is where it gets you. There's not one answer. You have to determine what the requirement is. Maybe it's down here after step 5 when the customer selects withdraw. The system goes out and pings the bank, and there's a network error, and blah blah blah, it times out. Or maybe, no, it's not at step 5. Maybe as soon as they validate the right customer, the first thing they do is go out to the bank and verify they've got an account there. Whatever the answer is, you have to determine, what happens, or where does that get detected? Or maybe it's detected, quite frankly, right at the beginning. You insert your card, and the response is, sorry, can't do any transactions, network's down, try later, or something like that. Or maybe it's not even that. Maybe it doesn't even let you enter the card. But again, you work that out. But it's an alternative flow. No cash. This is interesting. I mean, no cash might be something that's no cash in the ATM machine. Normally, they don't even let you try. Well, actually, I've had some where you actually try a transaction, then it tells you it doesn't have enough cash. Like if you want to withdraw $100 and it's only got 50, I've had one machine actually output like 40, because I think it only outputs 20s. Yeah. It'll output 40, then it tells you on the receipt it can only give you 40. Well, this happened to me, and I was like, I got ripped off. I asked for 100, it only gave me 40, and I started banging on the machine. I didn't read the receipt. It's like, oh, okay, yeah, I got it. So, but there's interesting behavior there. Low balance, of course. Where does that come into play? So you get the picture. You don't have to re-implement this entire thing. You can just say, hey, you know what? At step 5, instead of this happens, and just it operates just the same up to step 5. So you can kind of weave that into this discussion as well. It just simplifies a lot of the redundancy in creating these, because if you're creating, like in case of this American Airlines Sabre system, if you're creating 200 or 300 use cases, each with multiple different alternative flows and exceptions, that's a lot of paper. So you want to do whatever you can to reduce the amount, of redundancy and that type of thing. Now I call this, these are usually the exceptions. An alternative flow, I've seen some people use alternative flows as a replacement for exceptions. It's all under the same term. In some cases, alternative flows could also mean just the different ways of withdrawing cash. Like you can withdraw savings. An alternative flow is withdraw checking, etc. But these are different ways of describing paths through that use case. I described one path, which was withdraw from cash. You can have others as well. Okay? Does that make sense? Yeah.
Is there any you can use for the negative points?
For what?
For the negative points?
Negative points?
Yeah, kind of like it's a misuse of networking.
Yeah, we're gonna get into that. Let's see if I have. Yeah, let's go back to the notes. I think I'm gonna get into that tonight. The misuse.
Not misuse, but kind of like you told me the first scenario that you and your manager you evaluate and explained it. There can be the negative points too, like it's saving the manpower, but it's taking more network, more electricity.
Yeah. Okay. Those negative points. Yeah. So now, if the negative point is something that's more of a non-functional requirement, it may not be. It may be hard to represent it in a use case because it's only functional. But some, like for example, performance is very hard to show in a use case diagram. So it kind of depends what the negative points are, I guess. If it's security, if the system you're building required, you've got to go do all kinds of fancy things with security, that might be something you can show here. Like, you got a prompt for this, you got to encrypt that, you can add some of that into this. So it kind of depends on what the negative point is you're trying to make. Okay, so I deviated from this, these trigger points and fail conditions. I don't use this a lot in my work, but I think what's really important is to talk about the short story. The alternative and exceptions are really important. You get all that done, you've got a good handle on, not all, but a good majority of the requirements. Functional. Here's a scenario that I tried to draw for you. I just put it in the notes. You can read through it. Notice here, this is another form. Sometimes just a 1 to n. The use case begins when the bank customer, so it always starts with the actor doing something, then the system, so you can go back and forth. This is just a sequential, so you notice it didn't have the little picture areas where you can draw the little prototypes. Again, unless I tell you otherwise, you can use any format you like. If I tell you to do a storyboard, you may want to do it the way I just showed you in the notes, kind of put it into the use case scenario. And we'll talk more about, I won't ask you to do that until we talk again about storyboards coming up. So when you're doing these scenarios, keep in mind these can apply in different situations. I talked about the storyboard, again in the film industry. I showed you what that looked like. You can even have very high level storyboards. This, believe it or not, is kind of a storyboard of, someone. What do you think the storyboard says? This basic storyboard says some guy gets a call, he makes an airline reservation, he flies to Paris to see the Eiffel Tower. Pretty high level storyboard, right? Television commercials are done using concepts like this that span 30 or 60 seconds, but they can be at any level of detail. I'll come back on that. Now, if you look at this use case driven activity we've been doing, a lot of these can apply and get evolve throughout the life cycle. So we're down in this phase, elicitation. That's what we're talking about tonight. The interviews, the JADs, all that is elicitation. Story or use cases are considered an elicitation technique. The process of discovering how one or more actors interacts with a system to produce something of value is a semi-structured technique of getting a lot of requirements of the system. That feeds into the other parts of the life cycle, and we'll talk about some of these. You can specify some of the use cases as domain objects. You can model them into subsystems, which we're going to talk about. That's the next section. If you're doing object-oriented, you can it'll actually tell you some information, especially on the interfaces, of how to implement those with either object-oriented classes or regular software components. And my favorite, I take use cases developed early on, and I feed them. I literally give them to my system testing team, and they use those to start designing test cases. Notice, I tried to make that analogy when I was showing it, like what did I say a precondition was? A precondition is how you would initialize a test case or initialize a system. The typical course of events is how you would test it. The postconditions is the expected results. It's the state of the system when you're done with it, right? So these, as a matter of fact, this scenario is a system testing team can take this and literally implement this as a test script, and it can look at preconditions as how to set up the system, and the post conditions is how to what to look for at the end. For example, check that the guy's credit or check that the guy's bank account has been reduced by $100. It can go, that's an expected test result, right? So you have everything you need to create a system test in these scenarios. So I use that a lot. So I'll take this document, feed it to my testing team out in Beijing, and they implement new tests based on that. So keep in mind, again, functional and not so much on the non-functional side as far as use cases are concerned. Now I mentioned, just to come back to it real quick, I mentioned the idea of trying to stay away from design-centric decisions and try to make it very kind of, I'll call it technology agnostic, right? These are called essential use cases. So the word essential is the key term here. Essential means you try to make it technology agnostic. So look at this little use case example for getting foreign currency. You'll notice by the verbiage I'm using how it's really kind of general, and it leaves a lot of the implementation details up to the designer. So it says here, identify self. It doesn't say type in the username and password, for example, okay? Because maybe the guy wants to identify themselves with a retinal scan or a fingerprint, right? I mean, I can do that on my cell phone, right? I don't have to type in I can type in some of my PIN. I just put my thumb there. So however you want to do it, just, hey, you know what? I'm going to identify myself. Then the system is going to validate my identity. Okay, I'm going to select the currency required. I'm not going to type. I'm not going to select the key or button or press. Those are all implying I'm doing a very specific thing with an I/O device. So I'm not going to say things like type, or tab. Again, I leave that out. Any way you want to select, you want to do a touch screen, whatever you want to do, just select the currency required. Enter the amount of foreign currency. I'm not going to type it in. I'm not going to shout it in. I'm just going to enter it. However I want to do it, I'll decide that later, etc. That make sense? So when you have a technology agnostic, and a lot of times this is done under designing user interfaces because you don't want to tell the user interface developer that they have to put a specific widget in a certain place. You just want to tell them, here's the function I'm trying to get done. You decide what the best widget is to do that function. So this is called an essential use case. Okay. Here's some storyboards. Now this, when I was living in Houston, I recorded some courses in a Houston filmmaking studio using a crew, and in between, on the breaks, I'd walk around this big area where they would film commercials, and I'd see things like this laying on the table. This is called a storyboard. What it does, this storyboard, it walks you through. Obviously, here it's how much kids like to eat hot dogs and how they like to eat at this place. This is kind of think of it as a trailer. A bunch of pictures that show the sequence of events of the commercial someone's trying to tell. Obviously, they're trying to plug Pup and Taco, and they're trying to show how people are really happy, and they drive here and they order their food, and they're really happy when they eat it. Okay, that's a commercial. That's called a storyboard. It's usually a sequence of pictures, almost like a cartoon strip, but it shows you how you want it, in this case, a movie or a commercial, to progress. Very common in the movie industry. That's why it's called a storyboard. We can also do the same things with our products. So if it's important to show our product in the context of a certain environment or what have you, you could sketch out how you want our product to work in that environment. Okay? I showed you one earlier that was, this is very high level. I showed you one earlier that was more of the screenshot. So now here's a storyboard showing, okay, let's say this is an interaction with a hotel reservation system. This little cartoon talks about how an actor would go up to a clerk using your computer and how they would perform a transaction and get their room keys, okay? Very high level. You can also take it down to the screenshot level, like I tried to draw earlier. You can actually saw GUI, like low fidelity prototypes. See this little text over here? See that text? This scribbling? Well, that's essentially what I was trying to do with this. So the scribbling text was this text, right? And then the little screenshot, and then the text. Screenshot text, screenshot text. Well, that's kind of what this is doing. Screenshot text, just a different way of showing it, right? But very effective. And if you can show some nice arrows that go back and forth between these to show the nice, easy progression. So very effective. I like that approach. It forces you to think about how one would navigate an interface to get a certain task done. More on this a little bit later, but very effective with eliciting requirements for what needs to be on the interface to get a task done. Okay, now how about negative scenarios? There was a comment earlier. Let me extend that discussion a little bit. Now, we talked about alternative scenarios, we talked about exceptions. I type in the wrong PIN number, blah, blah, blah. How about when someone is actually trying to do something harmful to your system, like hack into it, steal the money out of the guy's, have you all heard about the Target incident, right? What happened with Target? Yeah, well, actually, with Target, what they were able to do, what the hackers were able to do, is put some malware right at the point of sale system, right? So they didn't intercept it in the back room or on the database, or they were able to get some malware onto the point of sale terminal, and they were able to capture information off your credit card in the very brief moment it was exposed before it got encrypted, and they were able to capture that. Okay, so they were able to hack in and not hack in. They were able to capture that information with a little malware program that they put on the point of sale. So there are many situations where people will try to do harm to your system. I think I talked earlier in the safety critical part about how, that one guy in Austin was able to hack into the auto dealership computer systems and lock all the cars in the parking lot, right? There's stuff like this going on all the time, right? Apple had an incident, in a cloud-based incident. So this is a really big issue where people are out there trying to do harm to your system. And so we have to think about this now from a requirements perspective, as opposed to trying to deal with it after the fact all the time, right? So negative scenarios is a scenario where someone is trying to do something undesirable from the business organization's viewpoint. But it is desirable from the hacker's viewpoint, right? And that hacker doesn't have to be human. It can be a machine off doing some things too, right? So it's good to consider these beforehand because it may lead to other requirements that you have to document. And it's much easier to do that in the requirements phase as opposed to try to deal with it when a product's in the field. Why? Because Target found out the hard way, right? Target, from my recollection, is the only Fortune 50 company whose CEO got fired because of a security breach like this. Sorry? What was this? Oh, yeah. Well, anyway, it's something where you don't want to find out after it's already done. That's my point. You want to try to cover it early with requirements. So that's what this is about. Oh, that incident? Well, the negative scenarios, they're not documented ahead of time. Yeah, I think it's, yeah, in some cases it's a discussion where you get people thinking in this alternative approach, and you can cover some of it. You may not be able to deal with all of these, but it gives you, I think I mentioned the example of my friend who works for Raytheon, how his job was just to figure out how to hack into their shipboard systems. And then he would go back and tell them how he did it, so they would fix it. That was all done during the requirements phase and early design phase. So he would, so he was there to help drive new requirements into the system to prevent certain breaches. So it can be done at different times, but I assert that you can deal with this now and come up with what I'm going to show you next, which is a misuse case. So thinking about these beforehand, I think is the right approach. Now, the way you do that is we're going to invent something called the misuse case. So basically, you know what we talked about what a use case is, right? We start from a normal use case diagram. Here's a nice customer, very nice, friendly customer. They want to browse a catalog. They want to register a new customer, let's say. And then we go off and we find these misactors, these hostile roles, people that we want to harm the system, or one of the stakeholders, potentially, or just achieve some goal that's incompatible with the system goals, like maybe it's siphoning off some money into a different account or what have you. So in other words, it doesn't harm the system, but it's not doing what you want the system to do, right? Competitors, crooks, and the like. Then you discover or think about what could possibly be misuse cases. You do that by asking what one of these misactors would do to actually harm the system. For example, a competitor out here could flood the system with a denial of service attack, right? They could. A crook could attempt to steal the passwords. Like, again, I'm just throwing out the example of Target is one example with some malware. So you have almost like a brainstorm. You ask, what would a misactor do to harm the system? What are the goals? If you need to, create your own scenario. Go back into the scenarios that you've created and elaborate a new scenario on how they would specifically go do a certain task, okay, to harm the system. And then add the relationships. Now, notice how it says here, threaten. What have I done from this picture where I had a nice customer actor and use cases? Now I've added, what are these guys called? These guys are the misactors. And these are called what? Misuse cases. And you have to also say which use cases do these misuse cases threaten? Because some of these misuse cases will threaten certain use cases but not other ones. So this little arrow that says threatens means that this specific thing I'm talking about, flood system, threatens the register customer use case. Same with steal password. Okay, step 2, got it? So step 3, now you have to mitigate the use cases. So what would you do to, you know what, let's assume that they did these things. What can I do to neutralize them or make sure that they don't have a serious effect? So what would you do to neutralize these threats? Well, I can create a new use case, like block repeated registrations. And actually flood the system would not, in this case, would not be specifically a denial of service. It'd be more like flooding the system with names, duplicate names or something like that. So one thing I can do here is I can say, okay, I'm going to add a new requirement to block repeated regressions. And if I do that, I should be able to mitigate this misuse case. And I'm going to add block repeated registrations. I'm going to extend register customer use case. Now, I haven't talked about extends yet, but what extends means is, think of it this way as, this block repeated registrations is additional capability added to register customer. It extends it, okay? And down here, well, if I encrypt a message, the messages, I can mitigate this steal password. And that's an include relation. What that means is that register customer is going, it includes this already, includes this, and I may strengthen it, I may add to it, but it's part of register customer as well. So block repeated registrations may extend it, add new capability that I may or may not want to use in different scenarios. Includes is going to be, this is part of register customer that I'm going to add. This include can also be included in other use cases too. I'll get to that later. But notice how these two new use cases now mitigate these misuse cases. So let's rehash real quick because it gets confusing. Step one, start with your standard use case diagram that we already talked about earlier. Think about hostile ways of harming that system. You'll end up with misactors and misuse cases that threaten one or more use cases. Draw that picture, then say, okay, how do I mitigate those? I have to, normally I'm going to add more capability to an existing use case or add a new use case. Usually that's the way most of this is done. In this case, block repeated registrations and encrypt the message, okay? Encrypt messages. Okay, makes sense? So in your homework, I ask you to do regular use cases, okay? That's out there now. And then there'll be another one that'll actually do some misuse cases. I'll give you a system, and it's going to require you to just kind of think up of some interesting ways that you can violate this particular system. There's not going to be any one right answer. I'm just going to ask you to think of ways you would, harm this financial system or break into this medical device, and you're going to have to. I'm just going to ask you to come up with some interesting ways. You don't have to prove it. Just come up with interesting ways and then show me how you might mitigate it, just to go through the 3 steps. So just keep that in mind. But the homework that's out there now is just regular use cases, I believe. Now, so what are the benefits and risks of doing the misuse case? Well, I think there's a lot of them. More and more in today's world of large software systems, security and safety are really, really important. Just today, before I drove up here, I listened to the CTO of Green Hill Software, which is a software company that builds operating systems, and they're the only operating system in the world that has achieved the top level of security compliance, which takes about $1 million to get to. They were in talking to us, a large group of us today, about security challenges, and it's just getting worse. It's getting really, really bad. And you see it on the news all the time, right? Apple, car, everything is getting hacked into. So as this becomes more and more important, unless you've got a safety or security guy on your staff that's really knowledgeable, that can just tell you exactly what you need to do, going through this use case, misuse case, just having that discussion, it will, at a minimum, raise some interesting questions about what else you need to maybe add to your software from a requirements perspective to help mitigate that. Early identification of threats and mitigations. Again, doing it early before someone does something harmful. Also, early identification of the test cases. Anytime you have a misuse case and a corresponding use case that mitigates it, you can then test it to make sure it worked. And then documentation of the different rationales. And then the risks. It was mentioned earlier as well. You could get into premature design in steps 3, like in the mitigation here. In some cases, you have to be careful here. If you're at the right level, it's fine, but you could, in order to design the right mitigation, you may have to dive a little bit into design. My take on this is that's okay in some cases. It's okay if you dip into design every now and then, as long as you're not living down there in design and designing the system. So the goal should be to find, again, you're trying to find requirements. That's really what we're trying to do. Missing misactors and threats. Again, if you can always miss one, not cover the whole spectrum of possible threat. It is always good to have someone that kind of understands security and safety that could help you as a stakeholder when you're building these. If you're new to that. if you look at some of these data gathering techniques, and I'll stop here and then I'll let you, because I think the homework covers up to this, and then I'll do a quick review of the homework. I'll let you guys go. Like I said, I've been talking since 3:30, and I'm kind of running out of steam anyway. So 5 hours nonstop. I think I'm going to take a break. You look at the different data gathering techniques. We talked about questionnaires. Good for answering specific questions because you can ask them in that context. It's good for getting quantitative as well as qualitative data. You can also read body language when you're doing this and get a good feel for how comfortable or uncomfortable a customer is with a certain type of capability or requirement. You can get to a lot of people with relatively low, like for example, I've gone out to conferences with one product I built. We took a prototype out to the Embedded Systems Conference, and remember back to the food comment? We offered free lunch to anybody that would come in and evaluate our product and give us feedback. We got a crowd of people, and we got a lot of data with a lot of interviews as well as demonstrations in 1 hour. So you can reach a lot of people. If you know, again, we put it at a conference, so it was where a lot of people already were, but you can reach a lot of people. But the response rate may be low or not what you want. When you're interviewing someone, if they're not interested, if they're, you know, if they got something on their mind, their car's in the shop, their spouse is in the hospital, they're not going to be into talking to you, you know. So there's always a minus there. Interviews, focus groups, observation. Let me talk about observation real quick, because I didn't talk about this. Has anybody ever watched Jane Goodall? You know, the person that went out and studied apes in their environment in the jungles. Anybody remember her? Probably not. Okay, never mind. You're too young. But there's this concept called ethnography, and ethnography means studying someone or something in their native environment. So for example, if you want to really understand how gorillas, which is what Jane Goodall did, if you want to really understand how they interact or social activities and things like that, you don't observe them in a zoo, right? You observe them in their natural habitat, right? You know, not in a constrained artificial. Now what's the equivalent to an engineer? You don't want to always observe the engineer in an artificial lab or in a conference room when you're trying to ask them to do something. You want to observe them where? In their natural setting, you know, in the lab, you know, wherever they're using your product. I was on a Continental Airlines flight a few years ago flying overseas, and I saw a guy observing, he was across the row, and he was observing the guy in front of me, looking at him for quite a long period of time. I started getting a little bit worried what was going on. After dinner, I finally heard him talking. The guy was observing a guy on his laptop on a plane, and of course, you know, there's always cramped room, not, you know, and screen, you know, you're never in an ideal environment. And the guy was from Dell. He was observing the guy operating his computer in their natural setting. In this case, it was on an aircraft, you know, because a lot of people do work on airplanes. And I heard, and they were talking afterwards. I only caught bits and pieces of it, but he was looking at some of the, you know, some of the things they can do with their new laptop designs to more accommodate business travelers on airplanes. But the only way you get really good information is by observing the person using your product in that kind of natural environment, right? So that's what this naturalistic observation, sometimes it's called ethnography. You can get some really good data. Now, if you have to observe them over long periods of time, like in the lab for 5 hours in the middle of the night, you know, at 2 in the morning, or if you have to videotape them or whatever, you could consume a lot of time and effort to do it, but it is worth it if you can get the data. And I talked about documentation. So, you know, a lot of techniques, they're good for some things. They get different types of data, and they've got pluses and minuses. Just familiarize yourself with this. We talked about a lot of it, but the point is, when you're doing data gathering in that initial elicitation phase of requirements, there are certain tools or techniques that will work. In some cases, they'll work better than others, so it kind of depends what data you're looking for. So pick the technique that's best matched to the type of information you're looking for. Okay? So this next section, we're going to get into a lot more of the modeling. But let me quickly turn to the homework. I think I put 4 out there. Okay, we talked last week about some of the processes, right? Software processes, remember? Hasn't been that long, guys. Spiral, waterfall, incremental, iterative. Okay, so part of this is dealing with that, but I also want you to think about a couple other things. This first one, I'm talking about this virtual museum system. And what I'm asking you to do is, because you have to deal with this a lot when you're looking at requirements for some systems, is brief description of the system. And I want you to tell me about what political and organizational difficulties might you encounter when you're trying to build a system like this. Organizational and political difficulties, what's another? We talked about this. If you go back to we talked about this when we talked about constraints. Remember we talked about organizational and political constraints? We go back and look at that one blue table with all the different constraints in it. If you had those two constraints of a political, maybe organizational constraints or difficulties, I want you to just think about it. What might happen? What might occur if you're building a system like this? Keep in mind, this system, you're developing this system for a consortium of European museums. Anytime you get all of Europe involved in something, they never agree on anything. So again, think about the political and organizational difficulties. Brainstorm, come up with some ideas of where you might at least be a little bit concerned, okay? Short answer. This next section, number 2, give reasons for your answer. I want you to take these 4 systems, and I want you to tell me the most appropriate software process that you would use. Again, that can be waterfall, incremental, iterative. We talked about all those last time, right? Pick the one you think would best apply to this type of system. So you go back and read about the pros and cons, which ones are best suited for which type of product, and try to map those into these products, okay? So the answer is just one of the process models. I think you should probably, don't just say, pick one of these, don't just say like waterfall. Tell me why you think that would work better than the others. So, and then a few others related to that topic from last week. Explain why programs that are developed using evolutionary development might be difficult to maintain. I want you to just give me your thoughts on this. If you do find a reference, please cite the reference. I mean, who knows? Sometimes there'll be a discussion online on the same topic. I'm okay if you do it, use that, but just say, hey, I agree with what so-and-so is saying on this chat thing, and just give me the link, and that's fine. Explain how waterfall, both the waterfall model and prototyping can be accommodated in the spiral process. Think a little bit about how that might work. We actually talked a little bit about that, and if you look at the spiral model, you can see prototype in there. Just go figure out how you think you might be able to weave both of those into a nice spiral process. And then finally, explain why a software system that's used in a real-world environment must change or become progressively less useful. You put a system out there, you think you got all the requirements right, almost always you didn't. And plus things change all the time in the real world. Just think about why must it change or become less useful? What makes it become less useful when when you deploy it? It's almost like, kind of like buying a car. As soon as you buy the car, it starts to lose value and atrophy and get old. What do you need to do to keep that car going and new and valuable to you, right? If you bought a car a long time ago and there was no air conditioning, obviously it's not as useful today, but what can you do to make that old car you bought in the 60s more? I have a, in my garage, I have a 1973 Corvette Stingray, a nice classic car. I refurbished it. It has no air conditioning, so I only use it when it's cool outside. It's still useful. I had to fix it up. I had to add a new stereo to it because it was less useful. Back in those days, all they had was an AM radio. Now I've got a stereo in there. I got to, So think of that with a software product. You put it out there, it's going to immediately start losing value. What do you have? Explain why it's what you have to do to keep it useful for as long as you can. And a lot of it has to do with requirements, right? How do you get these new requirements? How would you know whether that product had to be updated? Does someone email you? Does someone stop buying your product? Think about that. It's one of those questions that we'll get into later on in the course, but just think a little bit about it now, okay? Give me your thoughts. So that's homework 4. Let me quickly go to homework 5. This is a use case exercise. We just got through talking about use cases. Now, in this one, I'm giving you a medical information system. And I'm not going to read through this, but I describe the medical system. I give you some basic high-level requirements for the medical system and things that it has to do, okay? Think of, when I say things like high-level things that the system has to do, in your mind you should be thinking use case, right? Read through this and then develop a use case diagram. Remember, what is a use case diagram? It has 4 parts. Remember that thing I showed you? Develop a scenario for at least one of those use cases based on the template discussed in class. What I would do is show the template in the notes. I want to make sure, because it doesn't say it explicitly, make sure that in your use case scenario you have the typical course of events, you have the preconditions, post-conditions, like we talked about in class tonight. If you want the notes, first come, first serve, it can give you some extra guidance on that. So develop a scenario like we talked about in class, and then develop at least one alternative scenario about the system. Now, alternative in this context did not mean misuse case. Alternative mean alternative flow, right? Remember that? There's a difference. Alternative flow through the same use case as opposed to misuse case. That's homework 5. Okay. Next week, I'm going to have a tape for you, and we'll get into some of the modeling parts of the course, and then I'll be back the following week, and we'll just pick up, kind of from where we left off and move on from there. Okay, that makes sense. Okay, and I'll do my best to stay caught up on the homeworks as well. If you do have any questions, again, just drop me an email, and I'll do my best to explain, or when I'm back live, come up and see me, okay? Thanks, guys. See you next time.